Okay, so we're going to take a look at Coding Lab 2, and we're just going to, I don't really have a script for this, so we're just going to kind of play it by ear, and I'm going to try to explain this stuff as well as possible. So the whole point is we're trying to write a Python script that will calculate statistical values. Okay, so we can't really do anything unless we have libraries involved, um, and you'll see where we use that as we go through this stuff. So the first thing I want to do is I always start my codes with a preamble where I'm importing the libraries that I'll need. Let's see. So for this one, I'm going to start with. So we've talked about this before. I'm telling the program to bring in the library NumPy, and I've given it an alias np. That way, anytime I use it, I don't have to keep typing NumPy. I can just type np dot whatever. Since we're calculating statistical values, oops, we're going to also bring in the statistics library. Okay, so what we're going to do is we're just going to try to see how many different ways we can calculate some of these numbers. So the first thing I need is a set of data that I can use. At some point, I'm going to show you how to have the program prompt you to type to input your data, and then the program will run with whatever you input. But for right now, I'm just going to make a list. I'm just going to pick the variable x. My list is going to be inside square brackets, and then let's see, I'm going to do 0.56. And you want to separate the inputs in a list by commas. Then I'll do 5.55, 6.48, 2.47, 3.21. So, I mean, maybe this is data you got from an experiment you were doing. I mean, granted, you can tell this, it's not very precise, but still, it's data. Okay, so the first thing I want to do is look at what's called a for loop, and I kind of want to get an idea of how they work. Okay. Now, I'm going to go ahead and put the print command with empty quotations inside of there. This is going to be something I use for housekeeping. It's going to make the code look better when it spits out. It's going to make what the code spits out look better. And if you look over at the lower right hand of my spider screen there, that's the terminal. That's where all of that's where the script will print out what I'm telling it to print out. So, for example, let's just say for I in X. Now, what that means is for every input in the list X, and so each one of those numbers will be an index I. So now remember, in Python, your lists, they index from 0 to whatever. So in this one, you have 5 inputs, but it indexes from 0 to 4. But all that I is going to do, it's going to pick one of them. It's going to pick the first one. And let's tell it to then go ahead and print I. So when we run this, so watch on the lower right-hand side, we hit our little run button at the top of the spider screen. So what you notice is that it picks each number from the list X and it prints it to the screen, and it keeps doing that until the entire list is done. That's what a for loop does. So I'm saying for each input in the list X, print out the input, and it will just keep going until it reaches until it finishes the whole list, and then the loop will terminate. Also notice for a loop, you notice how my first line here, my for line, is all the way over to the left. And so I made my for statement there. And then you get a colon. My next line is indented. So now everything that's indented will be inside the loop. And I'll give you a better idea of what that looks like here in just a little bit. But if we want to continue with our, hang on. Okay, I do want to take a moment to look at a couple of things. If you look at the spider over here, notice in this far left column, I have those two triangles with exclamation points. Well, what that's telling me, those are called warnings. And Spider's telling me, hey, you didn't necessarily do something wrong, but these two libraries, you told me to bring them in, but you haven't used them. And that's really all it's telling me. It's like, hey, are you sure you wanted to do this? So that doesn't necessarily mean you've made a mistake. If there's a mistake in your code, you'll get like a red X over on that far left column. But also, you'll see error messages in the terminal window, which will show you the line where the error is at. Also, there's a lot of things that my Spider's not doing. So I'm not getting like code prompts to, hey, you could complete this, but there's a lot of little windows that can pop up as you're typing code. If you go into tools and you go into preferences, you can really personalize how your Spider works. I just turn those off, all of those little pop-up windows. Now, so that's my first for loop. I'm going to go down. Now, you see me leaving a blank line at the bottom all the time. You don't have to do that. That was something I started doing in graduate school because the programs that I used would tend to spaz out if I didn't have a blank line at the bottom. So now it's just a habit. So what I'm going to do is I'm going to keep printing out all of the stuff that I have this program doing. I do want to show you something though. This is called commenting something out. Let's say you write another block of code and you don't want this first block to run when you run the code. So I'm going to put 3 exclamation points at the top of the block of code I want to comment out. Not exclamation, quotation marks. And then I put 3 quotes underneath it. So now everything in between those sets of quotes is now a comment, and the Python interpreter won't run them when you run the script. So, like for example, if I hit the play button, you get nothing because that for loop is commented out. There is a second way to comment out. So you can do 3 quotation marks and 3 quotation marks, put your comment in between the quotes, or you can do a hash sign. That also turns a line into a comment. And I'll talk about commenting here in a little bit. You're going to want to learn to comment your scripts because in the programming industry, that's just common courtesy. In graduate school, I've gotten scripts from people who didn't comment, and I would spend days going through thousands of lines of code trying to figure out what each block did. All right, let's now I'm going to do another for loop, and I want to use this mathematical symbol here, and I want to talk about what it does. So I'm just going to say for now for that first for loop, I picked I in the list X. I don't know. It doesn't have it can be anything random. For B, you know, might use B later. For Z in X. Again, Z is just going to be the index. So now I'm inside the loop. Now let's do this. Plus equals Z. Okay. Now you see the red X. It's telling me I have a mistake. Let's try and run it. Oh, there's the error. So you see that arrow pointing at line 14? That's telling me, hey, that's where your error is. And it says total is not defined. Well, what that means is I'm trying to use total as a variable. So I just called it total. You could call it anything you wanted. It's random. It's whatever you come up with out of your head. I called it total because I'm trying to sum up all the numbers inside of X. However, there's no variable called total that's been initialized for this loop to use. So it doesn't know what I'm talking about. So what I'm going to do is I'm going to initialize the variable total, and I'm going to set it equal to 0. I'm just going to essentially initialize it, make it empty, and ready to receive input. So now when I run it, okay. So look what happened here. That plus equal sign. So what that's going to do is it's going to take, and you see I use the index Z, which is going to index each number in the list X. So what that's going to do is it's going to take the number that's already in total, then it's going to take the next index from X, add it to what's in total, and then reassign total as the new number. So you see, initially it took 0, and then it took the first number out of X, which is 1.56, did 1.56 plus X, and then reassigned total equals 1.56. And that's why you see that as your first number. The next one is going to be 1.56 plus 5.55, and then reassign total as that new number, which is this huge 7.1, 0, lots of nines, so on and so forth. That's what the plus equal does. However, we do like our data to look nice. So we have that really long, obnoxious number there that it printed out. And Python will sometimes do that, but we can tell Python not to do that. And this is called formatting. So I'm just going to call this new variable tot, which is so short for total. And so I'm actually going to define the variable now inside the loop. So this is something you practice with, whether you need to initialize a variable or you can define it as you go. You'll get used to it as you practice. But what I'm going to do is the format that I use. So I'm going to do quotation marks, curly brackets. Then inside the curly brackets, I'm going to do colon, which means take the whole thing, dot to F. And so what I've done here is dot to F tells it 2 decimal places. This type of formatting, the two letters I use most commonly is F and G. F tells Python to format to a number of decimal places. G will tell it to format to a specific number of significant figures. I just want 2 decimal places. So then I'm going to tell it dot format the number total. And then I'm just going to print out the new variable that's been formatted. And you notice they're all very nice now. So that's what I did. I just formatted to 2 decimal places, trying to clean up my my output. However, this little loop here was designed because to calculate the sum of all of the numbers, all of your data. So because the first thing we're working towards is the mean value. Great. I don't necessarily want it to print out every single number as it's doing this. Okay, so I'm going to remove the print from inside the loop. I'm going to go down a line, and then I'm going to backspace back to the left. Now, I space down a line just because I think it looks nicer. You don't have to do that. To get out of the loop, you just space back to the very far left, and you're outside of the for loop. So now I'm going to tell it print, and I'm going to make it give me a definition of what it's printing out, because that's always nice. So I'm going to go into print, and I'm going to put quotations. Quotations will allow you to type in a string, and the print command will just spit that straight out. So the sum of the numbers in X. So then I'm going to go outside of that quotation. I'm going to put a comma, and then I'm going to tell it to print the variable tot that we formatted. And so inside of a print command, you can have it print multiple things. You separate them by a comma. If you want it to print a string, which is the phrase that I put in there. You have to put it inside of quotations. So now what we're going to get, the sum of the numbers in x is 19.27. Okay, so and that's what we wanted to do. Now let's look at this a different way. Okay, so I'm going to kind of leave these together. Let's look at something that Python can do automatically. Now, we wrote a for loop here to get all those numbers added together. We also have this nice little function we can use. I'm going to call this variable the sum of x. Again, I just made that up. Sum of x equals sum parentheses x inside the parentheses because x is my list. Then I'm going to tell it to print again. So let's differentiate these. Sum number one of the numbers in x. And for this one, my quotation marks, and again, you could use double or single quotes, doesn't matter. Sum number two of the numbers in x. I'm going to go outside the quotations, comma, and then, oops, hang on. Note the new variable, sum x. And as you'll notice, they're the exact same number. So there's multiple ways you can do things in Python. Most of the time, I suggest using the functions that are built in because they make things nice and fast. You see that sum x, it just takes all the numbers in there, adds them together, which is really, really nice. Now, let's start talking about commenting. Okay. So let's say you were sending this code to somebody, you wanted it to be portable. Someone's going to open this and they're going to, what do your blocks do? Okay, well, I'm going to put a hashtag for a comment. So I'm just going to say this block here sums the numbers. Sums the numbers in the list X. That way, anyone who looks at this, and then I can say, I can either continue here, I can do a second quote. So I've summed the numbers in the list X, and I've done it two different ways. So now anyone who gets this will go, oh, okay, that's what this block is doing. Right. This is a courtesy that is actually pretty nice to do, and people who read your codes will be appreciative. So we've learned how to sum the numbers in there. I don't want to make these too long, so we might just get through mean value, and then in 2 weeks we'll do standard deviation and so on and so forth. Okay, so the next thing I want to calculate, let's see, I'm going to put these in. That's going to leave 2 blank lines between my sums and then my mean value calculation. Okay, so here's the question. How many different ways can we do this? So for anyone who runs this code, I want to have it So I'm just going to tell it that it's good. So it's going to print out that string, which will give a nice little heading. So as you see here, so now we're going to get this nice little heading that's going to tell us what's going to happen next. And even have it do like a little colon there and make it look like a new section coming up. So then I'm going to put a blank line between that and the numbers that I calculate. Okay. Okay, so you don't have to do this. I'm just numbering these so you can see them as you're watching the video. Procedure number one. Well, what is the let's see. Let me look up. Okay. Okay, so the mean value. Okay, so I'm gonna stop sharing here for a minute. Then I'm gonna share this screen. Okay, so you see the mean value formula that we're going for. Okay, so we want to have the sum of all of those values in X. And this is why I called that list X, because it matches the formulas you'll usually be able to find. And then we divide it by the number n, which is the number of inputs that are in that list. Okay. So we're going to go back to the Python screen. And so then, well, how can we do that? The first thing we can do is we can look and we can say X has 1, 2, 3, 4, 5 numbers in it. Okay, so that means n equals 5. Great. So what we can do is I can say, oh, let's see, the mean value. You saw that it had a bar over the X, so I'm just going to call it X bar 1, because this is our first way of doing this. That's just the variable name that I came up with on the spot, X bar 1. That's going to equal, and what we have the value sum X that we calculated above divided by 5. Okay, and so then we'll tell it I'm going to call this number 1. The mean value of X number 1 and let's see. Let's make this look more like a heading. So I'm just going to do there we go. That'll look more like a heading. Okay, so I'm going to tell it to print out that string, the mean value of X number 1, and then the variable that we just calculated. Okay, let's see what it does. Okay, so you can see that the mean value that we get is 3.854. You can do that on your calculator, and you'll see you'll get the same value. All right, let's see here. How about the second way to calculate this? Well, what about we go back up to the original, to our for loop that we did? Okay, well, what about X bar number 2 equals, at this time, tote divided by 5. Okay, let's print this and see what it looks like. Uh-oh, what happened? Error retrieving source, ABC, string int. Okay, oh, I know what it did. It didn't like the formatting. So we did the formatting to make it a nice printout. Let's go with the entire value total, because it'll still be the same number. There we go. Yeah, for the calculation, it didn't like the formatting. So, and this happens sometimes. Okay, but look, you see we get the exact same mean value. Okay, but what if you're putting data in and you don't know how long X is going to be? Okay, well, let's solve that problem. This is going to be calculation number 3. Okay, so what I want to do is I want to know, no matter how big X is, how big my list is, how many values are in there. So I'm going to call this len X, so length of X, because it mirrors the function I'm going to use, length of my list X. Okay, just so you can see, let's have it print len X. You see how it printed out a 5 there? So instead of just putting 5 in the calculation, I can actually set a variable to always know what the length of that list is, and this is how you do it. So this is just going to set a variable that says no matter how big X is, I'll be able to pull out the length of it. Okay, now the next thing we're going to do is we're going to say X bar number 3. That's going to equal, and this I'm just going to go back to using the sum that I calculated. Sum X divided by len X print. Okay, let's see what it does. Yeah, we get the mean value again. I'm just going to try something on the spot here. I don't see why it wouldn't work. Do number 4. Let's just say X bar 4. That's going to equal my sum X divided by the length of X. I don't see why I can't just put that command straight into the mathematical equation. And you're noticing here that slash sign is my division sign for Python. We're going to end up using a lot of these mathematical symbols, so you'll get used to them as we go along. So I don't know. Let's do print. Oh, I need to learn to spell better. 4. Bar 4. What does that do? Ah, we get the same thing. I'm interested to see why. Oh, that's because I put them. There we go. Yeah, now they all look good. Can I do this a 5th way? I can, and that's actually where the library we brought in is going to help a lot. Okay, so number 5. Okay, so for number 5, what I'm going to do is I'm going to say X bar 5. Now, this is why you're going to see why we gave an alias to our libraries we brought in, because I'm going to say st dot mean of X. So you see how I used st if I go back up, my statistics, I renamed it st. So if I didn't do that, I would have to have typed out statistics.mean after bringing in the statistics library. So I renamed it to make it easier to type out. Now I'm just going to print. Value of X number 5. And X bar 5. And I'm willing to bet, yep, I get the same value. So this last one is usually the preferred way to do it because it's a nice little function you can call from a library. It makes the code nice and short. But as you see, you can program in the mathematics directly. There's just a number of different ways you can do this based off how you're thinking at the moment, and it will work in each way. Okay, now I'm going to try to do a little add-on here. Okay, so trying to find a certain symbol. Give me a second. All right, found it. You know, you can actually have Python print out uh, mathematical equations. So we're going to need some new libraries for that. Okay, so what I'm going to do, I'm going to go back up. I'm just going to put them in my preamble. There is a symbolic library, SymPy, and that is in SP. Now, here's a new way you can bring in stuff. I don't have to bring in a whole library. I can say from SymPy import pprint. Pprint is a function in Python called prettyprint, and I can actually make it print out uh, uh, mathematical equations. So I'm going to try to walk you through this, and we'll talk about it as we go through. So, let's add it back up to the top, mean value calculation, calculating the mean value of x. Okay, so what I want to do is I want to have this print out the equation for the mean value. Okay, so we know that that's x bar equals the sum of all the values of x, and then over n. Okay, so let's go back down here. Okay, so I'm going to say, I'm just going to start here. I'm going to need a symbol x sub I. Let's make it easier for us to type. Let's just call that xi, x bar, n, I. I think that's all we need right now. And what we do, so those are just going to be my variables that I can call. I'm going to have this equal SP, that's the SymPy library, dot symbols. And then I'm going to define these symbols. So inside here, I'm going to do quotations. Then I'm going to say xi is x sub I. And you'll notice that it's going to print out the x with a subscript I, then a space. Now, I'm going to do x slash u 0305. What you just saw there is called Unicode. You can look up Unicode symbols, put them into a pretty print at the very least. I need to see if they work in the regular print function. But you see I said X, and then I put the slash in the Unicode for the bar that I want to be over the top of X. And that Unicode will print that bar out that when you see the average value over the top of the X. Then I'm going to do space. I want to have the symbol for n print, I, and I print. So I just put all these in here. I separate them by a space. I think you can put commas in, play around with it. Now, what I'm going to do, the next thing I'm going to do is I'm going to make an equation here where I say, I was going to call it mean equals now sympy.eq. So this is going to tell SymPy to print out an equation. I need my parentheses. The first thing that I put in is going to go on the left side of the equal sign. Okay, so x bar, comma. Now I'm going to put in the right side of the equation. Okay, so here's how we do this. Now I want to print out the sum. Okay, so I'm going to do sp.sum. All righty. I'm going to do another parentheses, and then that sum is going to be of all your xi's. And then I'm going to put a comma, and what I put next is going to be the indices on the sum. So I equals 1 to n. And you'll see that. So, okay, so the first thing you put inside the sum here is what, for the symbols, is what you're trying to sum. The second thing you put inside parentheses is going to be your indices for the summation. And so it's going to be I equals 1 to n. You'll see it when it prints out. Now, you have to make sure all of your parentheses are closed, but look how they highlight when I go across each one. Just going across each parenthesis will, parenthesis, is that the singular? Anyway, that'll show you, it'll highlight its pair so you can see if they're all closed or not. Okay, but I'm not quite done yet. Now, I want to divide that by n. All right, now let's see if I did this correctly. So I need to do pprint mean. So pprint, well, now we should print out the symbols, and yep, it did it. So it's not the prettiest equation, but you see that it gives you the x bar, which is your mean, your average, your mean or your average value. Then it does the sum, I equals 1 to n of all of your values in x divided by the number divided by n, or the number of inputs in the list x. So this is an extra thing. This is something you don't have to do. I just threw it in case you kind of want to review the code that I put in and see if you can, and if you feel like playing around trying to get Python to spit out equations, because it's just an extra fun little thing you can do. So this shows that at this section, this is the equation we're using for our calculation. I'm going to put in a blank line to make that look better. And as you can see, we now have calculating the mean value of x. We have the equation that does that. And then we have the 5 different ways that we were able to calculate the mean value of x, which you can see here. And so that's going to be enough for today. So the next time, so I'm going to try to do this every other week. And so the next time for Coding Lab 3, we're going to move on to standard deviation, which is going to be a little more complex. But if you get this down, it'll make a lot more sense to you. Just kind of look at how we brought libraries in, look at the structure of the for loops, play around with having Python actually print out equations if you want to, not necessary. But then play around with, so here you saw we have 5 different ways we came up with to calculate the mean value of the numbers in x. All righty, so we're going to go ahead and stop there. And I thank you for joining me, and I'll talk to you next time.